Hi everybody, this is Stephen Pugh. We're going to be doing another video. This one is on methods used to form openings in a floor. It's under the general heading of carrying out first fix flooring and roofing, Unit 207. And we're going to talk about the subject of trimming. Now, trimming is the process in which we make a hole in a floor. And that hole must be secure, it must be steady. Even though it's a hole, it must nevertheless be structurally sound. So the art of trimming is being able to make a construction that has a hole in the floor that is solid and is going to be safe. And this is by the use of trimming joists. Now, the trimming joists are large joists that run each side of the hole. They either run, if it's a hole that's a rectangle, they either run towards the sides of it, or the other way around, it can go across the front of it. But these trimming joists are usually double the size of a normal joist. So for example, if a normal joist is 50 millimeters, then it'll then be 250s, which is 100. And they're normally bolted together in various places to make a super strong joist each side of the hole or in front of the hole. And then we then have trimmer joists, which go across. So you've got the trimming joist, you then have a trimmer joist going across it. This encloses the whole space. That trimmer joist, okay, is also going to be a double joist, and it's going to be super strong. It's also going to be bolted together. And then in some circumstances, if it's a square like this and you've got a trimmer each side, you've got a trimmer joist going across the front, you then have trimming joists coming into it from the front. And those trimming joists will be the normal joist sizes. And so this is a very simple thing. There is another variation. Sometimes you'll have a 90-degree turn for a stairwell. And in those particular circumstances, the actual joist set out is a little bit different. You'll see on the plan when you go to the job, you'll see that they'll have very large trimming joists going right across. They will also have trimming joists going out into open space and enclosing. And they will be supported generally by a wall, okay? And they'll be sitting on that wall and they'll be spanning across that wall like that. So they'll be coming out into open space, but they'll follow all the ordinary rules of trimming. So as I said, the normal practice is to bolt two bridging joists together, and this brings a super strong joist for the trimming of openings. There are a number of ways that used to be done in the past to join joists together. For example, there was the tusk tenon joint. That's one of the most classic joints, and this is where two joists come together, but one of them is if I can try and get my fingers, one of them is a tusk and it goes through, okay, and on the back end a wedge is popped through. This is the most common and probably the best way of joining joists. Another way is to make a housing but a bevel on it. Another way is to make a square housing, and another way is to make a dovetailed stopped housing. I have to say the dovetailed stopped housing is probably one of the best because it doesn't just sit inside a space like the bevel and the housing does. It actually grabs hold of the timber and will not let it go. So even if the timber itself shrinks a little, it will not let it go. It is actually fixed to it. So now the more modern method of joining joists together is by the using a galvanized steel timber to timber joist hangers. And these are straps that go down the front of a joist, and they have a cradle at the bottom, and the joist fits in the cradle, and then it is pumped through of nails. So these are exceptionally strongly fitted. To take one of these apart is an exceptionally difficult thing to do, and they do make a super strong joint. Now, there are a number of ways that joists need to be trimmed when they're going around either a hot flue, or if they're going around a hearth, or even a hearth with a flue. The way in which that's constructed is it's constructed very much like an ordinary trimming operation. If it's to go around just one flue, there must be at least a 200 millimeter space between the side of the flue and the start of the joist on the one side and on the other side, and there must be at least a 40 millimeter gap between the brickwork and the timber face. This is to prevent the wood from getting hot. We don't want the wood to get really hot and then start to burn. That's obviously a bad thing. And around a hearth, there's various ways of going around a hearth, and people in the past used to have all their favorite ways of trimming around a hearth. The most important thing is that there are regulations in relation to this, and it's very, very important that we follow those regulations in relation to building around a fireplace. I'm sure you realize how important that will be, and you'll find that on plans that you're given, this will always be explained and this will always be described. Now I'm going to go through the basic method of installing a floor joists. The most important thing you'll need to do is to check the story height. Now the story height is the level that's from a finished floor level to the top of the floorboards on the first level or on the third level. That's the story height. And what you'll need to make a story rod. Now, a story rod is just a very long piece of timber. It might be a piece of roofing lath. It could be anything that's really long. And what you do is you mark on it the positions of everything. So you might, for example, use a story rod on a job to mark the positions of window ledges, to mark the positions of floor levels, to mark the positions of wall plates. And you literally just put it in the building and you mark the building off on the story height. And it's very important that buildings are put up at level and square, and so a story rod is a great way of checking the overall height of a story. When you're putting timbers into place, it's very important that you put the camber facing upwards. Now you may say, what's that? Well, we all know that on a piece of timber, pretend this is a piece of timber. On a piece of timber, it's laid that way up, okay? And we know that this is the side of the joist and that's the top of the joist. But joists, when you look down them, can have a curve. It's called a spring. Remember we talked about bow, which is that way, and spring, which is that way. Well, we're talking about the spring, and the camber is the top of the spring. So when you turn the timber over, you'll find that it's doing this. Now, it only might be doing it by a minute amount. Sometimes it's doing it by greater than you imagine. But the main point is that the crown or the camber must always be facing upwards. So that's how you select the correct timber. And then, of course, we cut them to length and we laid them out in place across the two walls. And the most important thing we need to know is that the first joist must be 50 millimeters away from the end wall. That's the point. It must be 50 millimeters away from the end wall. Now, all joist ends should be sealed with an organic solvent timber preservative, and sometimes they will be capped to prevent heat loss, sound, or air leakage. These are all the things that are important in the construction of a building. We don't want air to be going through the joist holes and making cold spots or even hot spots. The joist will then be, if they're coming across onto a wall, they need to be all leveled up. Now, of course, this sometimes is greatly alleviated by putting a wall plate. When you put a wall plate down, then we check the wall plate is level, and then all the timber joists will be level too. Now, there's also another important feature of floor construction you'll need to know about. It's the tying in of floors. So floors are tied to the actual structure to maintain stability and to restrict movement, which can be caused by wind pressure. And this is a requirement of the building regulations. It's laid out in the approved document A. And so there is galvanized steel lateral restraint straps. That's a big mouthful, but they're long L pieces. So a long piece of strap with a corner on it. And these are put across laterally, okay? And they're put on in sufficient numbers, usually every 2 meters, to enable the floor itself to be actually physically tied to the walls. So it's not independent of the walls. it actually is tied to them. Now, when it's going across a number of joists, it will need to have noggins put in, and it'll need to be buried just below the surface. But that's actually simply because you don't want to be able to feel a bump on the floor as you're coming across near to the lateral support straps. Now, there are rules and regulations in relation to the drilling of holes and notching of joists. You wouldn't thought there would be, but there are. And these are laid out in the Trotter span tables, which state that notches should be not deeper than 0.125 or 1/8 of the depth of a joist. And they should be positioned between 0.07 and 0.025 times the span of either support. Holes should have a diameter not greater than 0.25 or 1/4 of the times the depth of the joist, and should be drilled on the joist center where there is a neutral stress line. I'm sure you'll realize that on a joist, you've got a joist like that, and as it's bending downwards or bending upwards, the top is in compression and the bottom is in tension. So this is being pulled apart and that's being squeezed together. However, in the center of the joist, there's no stress, and that's the place where to drill the holes. Okay, so these are just laid out in the details, and you can always ask your colleagues. You can always look it up to discover where should be the correct place to drill holes. You just can't drill holes in joists wherever you like. It can weaken them if they're in the wrong place. And then we're coming to the subject of strutting. Now, strutting is a very important. This has got nothing to do with Scottish dancing. That's what's called the strutting of a dance. No, this is strutting on timber. And the purpose of strutting is because timbers all in a line, unsupported, tend to wobble. They tend to wobble, they tend to move, tend to flex. So that wobbling is restricted by putting strutting in between. The first and the most obvious type of strutting is solid strutting. This is where you put a solid piece of timber up against a joist, up against another one, and then up against that one, you then have another solid, and see a whole load of solid pieces of strutting going across a floor. Now, the disadvantage of solid strutting is that as timbers shrink, they don't just shrink in width, but they shrink in length. And it may be not very much. It may be just a millimeter or two, depending on how conditioned the timber was before it entered the building. Condition means that it's brought into the same overall moisture content as what the building is. So therefore, we don't get you don't get shrinkage. You don't let the timber come out in the rain and bring it straight into a dry building. It'll shrink. So that's called conditioning. So when that timber is put into place, it's very important that that timber doesn't shrink too much. Otherwise, the strutting will become loose, and then there's no point having any strutting at all. Now, there's another type which is very common, and it looks very pretty, and it's exceptionally easy to fit and very economic. It's called herringbone strutting. This is strutting whereby between the two joists, you have timbers that cross over between all of them all the way down the line. And these herringbone struttings, they're normally made out of 38 by 38 millimeter stock, and they are fitted between the joists, and they go top to bottom, bottom to top. So, for example, the one that comes down here meets up with the one on the opposite side of the joist, which then goes back up again. And the one that was over here comes up to the top and then back down again. So these struttings are always swapping over. And they're just pinned, and they're laid out in a very simple way. And at the very end of the floor, we have folding wedges put in. And what these, at one end you might have a solid piece of timber put in, and at the other end you have folding wedges. And as you're putting the folding wedges in, you'll hear the floor going boom, 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 boom. They go up a note as the floor becomes tight and as it becomes solid. So that's a very important point. Now, the third type of strutting is galvanized steel strutting. As you can imagine, these are just galvanized steel straps, and you literally put one from the top to the bottom, one from the top to the bottom, and put a nail in them all, and away you go. It's very simple, but you have to remember to tie them into the building, each side at the end. The disadvantage of steel strutting is the struts only come in certain sizes. They'll come in a 400, 450 or a 600 width. Whereas with herringbone strutting, if you've had to put a joist in a particular position for some reason, and you've had to put a trimmer joist in, you can then alter the size simply by just cutting a new one, and they're very easy to do. Now we need to just quickly talk about the tools and equipment needed for installing floors. The first and the most obvious is a circular saw. Now it might be corded or it might be a cordless, but the important thing is a small circular saw, absolutely invaluable. If you're cutting joists all day by hand, you'll know about it. But if you're using a small circular saw, especially a good quality, then you will find it'll save you a tremendous amount of work. Another thing is a straight edge or a string line. Now, when you know what a string line is, it's a piece of string that has some sort of coating on it. It could be colored chalk, or it could be that it's been in a dirty bucket of nails. And you take it out the bucket of nails, and as you flick it, so it puts a red line right across the timber, and that's very easy to see. The straight edge is an exceptionally useful tool when you're trying to level joists, and also the spirit level. Okay. Another thing that's becoming popular nowadays is the laser level. And you may be saying, why would you need a laser level or even a spirit level when you're putting joists down? Because there may be a slight discrepancy in the height of joists. And it's very, very important that you get them at exactly the right height. You don't want to walk across it later and find it just is moving under your feet a little. And you say, well, how do you make the height difference? Well, you can use tiny, small squares of DPC, or you could use slate. There's various methods, but whatever you do, you have to put something in that's non-crushable. You can't put corrugated cardboard in because it'll just immediately squash. You know, that's the sort of thing that we don't do. The other tool that's particularly handy when you're doing flooring like this is a nail gun. And these nail guns, they're just worth their weight in gold. They cost a lot of money, but they're worth their weight in gold because of the speed in which you can operate. There's a couple of things that you may need to just know about, and that is how to be able to make a check on the squareness of a floor by using Pythagoras' theorem. So you will measure, 4 meters, 3 meters, and 5 meters. And that would give you the squareness of the building. Roofing square is particularly useful when working with joists, and also a cordless screwdriver. All of these tools are going to be really essential when you're working on site. So there we are. We look forward to catching up with you next time as we talk about fixing joist coverings. Have a good day. Bye for now.